Advanced Math Set 93, Advanced Trig Identities and Triangle Inequalities. Okay, so the first thing that we're going to do is just do some trig identities. So these are just cases where we use what we know about trigonometry and then to prove that something is true. So this says, show that 1 plus sine b over cosine b is equal to cosine b over 1 minus sine b. So we're going to start with the left side and then do various manipulations to it to make it look like the right side. So the first thing that you can notice is that we have a cosine on the bottom of the left side, and we need to figure out how we're going to get that to somehow end up on the top and then have a 1 minus sine b on the bottom. So the first thing we're going to do is we're going to multiply the top and the bottom by cosine b. So we'll multiply cosine b over cosine b, and that's going to leave us with cosine b times 1 plus sine b over cosine squared b. Now, if you remember, cosine squared b is the same as 1 minus sine squared b, and we can factor 1 minus sine squared b. 1 minus sine squared b is the same as 1 plus sine squared b times 1 minus sine squared b. So now that we've got it in this form, you can kind of see where we're going. We can cancel out 1 plus sine b on the top and on the bottom, and then that is going to leave us with what we started to look for, which was cosine b over 1 minus sine b. Okay, let's do the next one. Show tangent b plus 1 over tangent b minus 1 is equal to secant b plus cosecant b over secant b minus cosecant b. So we need to take some tangents and turn them into secants and cosecants. So the first thing I'm going to do is take tangent and turn it into sine over cosine. So we'll do that with both the top and the bottom. And then, in order to get this to turn into secant b, I'm going to multiply the top and the bottom by 1 over sine b. So if I multiply the top and the bottom by 1 over sine b, I'm going to end up with sine b over cosine b times 1 over sine b plus 1 over sine b. And then on the bottom, I'm going to have sine b over cosine b times 1 over sine b times 1, or minus 1 over sine b. Now I can cancel the sine b's on the top and on the bottom. So I've got 1 over cosine b plus 1 over sine b all over. Cancel out those sine b's. 1 over cosine b minus 1 over sine b. Now, if you remember, 1 over cosine is the same as secant, so that's secant b, and 1 over sine b is cosecant. So we've got secant b plus cosecant b over secant b minus cosecant b, which is what we wanted to arrive at. Okay. Show x sine theta plus y cosine theta quantity squared plus x cosine theta minus y sine theta quantity squared is equal to x squared plus y squared. So the first thing we're going to do is take these quantities on the left and we're going to multiply them out. We're going to square them out. So x sine theta plus y cosine theta times x sine theta plus y cosine theta becomes x squared sine squared theta plus xy sine theta cosine theta plus xy sine theta cosine theta plus cosine squared theta. So it's a huge long list. Now we're going to put those xy sine theta cosine thetas together, so we get 2xy sine theta cosine theta, and we have x squared sine squared theta plus y squared cosine squared theta. Now we're going to look over on the second half of that equation that we're starting with. We're going to multiply that out. I'm not going to write it all out for you, but just refer to the first time, this part right here where we did multiply it out. Oh, it's not working for me. There we go. just refer back to that first part. I'm going to erase it because I know I've got writing over here. So we have x cosine theta minus y sine theta times x cosine theta minus y sine theta. That becomes x squared cosine squared theta minus 2xy sine theta cosine theta plus y squared sine squared theta. Now I have positive 2xy sine theta cosine theta and negative 2xy sine theta cosine theta. Those cancel each other out. And then I'm going to combine my x's together, and I'm going to combine my y's together. So if I pull the x's out front, I get x squared sine squared theta plus cosine theta, squared theta plus, and then I'm going to pull the y's out. So I get y squared out of sine squared theta plus cosine squared theta. And now you can kind of see what I'm getting at. So you have cosine squared theta plus sine squared theta in both, and we know that that is equal to 1. So x squared times 1 plus y squared times 1 is just x squared plus y squared, which is what we were looking for. Okay, now we'll talk about triangle inequalities. So the first thing that we're going to look at is when you have a triangle, the sum of the lengths of two of the sides of the triangle are always going to be bigger than the third leg of the triangle. So if you're looking at this example, C is always going to be less than A plus B. Because if A plus B was equal to C, then they'd be on the line C. You would just have this line right here if A plus B was equal to C. But in order to make a triangle, A plus B has to be a little bit bigger than C. So we're going to go through and talk about that. So in a triangle, the sum of the lengths of any two sides is always greater than the length of the third side. The shortest path between points M and N is the line segment MN, which I just highlighted. So that would be the shortest side or shortest path. In order to make it a little bit longer, it would be bigger than C. Okay, so we're going to look at a triangle, or three different triangles. The first triangle we're going to look at is the right triangle. So in all three of these examples, A and B measure the same. So A will always be the same length, and B will always be the same length for all three of these triangles. So in a right triangle, you can see that A squared plus B squared equals C squared by the Pythagorean theorem. In our second triangle, we have what's called an obtuse triangle. And we know that if we have A squared plus B squared, that's actually going to be smaller than C squared. Or if you put it the other way around, the hypotenuse is going to be bigger than A squared plus B squared. And then on the last example, we have an acute triangle. So C squared is going to be smaller than A squared plus B squared. We're going to go through and talk about each of these so you'll understand it. Like I said, A and B have the same lengths as they did with the right triangle. The length of C changes according to the opposite angle. So if you're looking here, you can see that if you have a bigger angle, C gets longer. If you have a smaller angle, then C gets shorter. Okay. Let's see. I'm getting lost here. Okay, there we go. Okay, so we're going to look at our first two examples, the right triangle and the obtuse triangle. So I'm going to take the obtuse triangle and I'm going to bring it down here and make it a little bit bigger. I'm also going to drop a vertical line, and I've created V and U that make that triangle a right triangle. It's basically the height, and then that dotted line that connects the height to the base. So we're just going to do a little bit of algebraic manipulation here. So if I said V squared, so this length here, V squared plus U plus B squared, so this length here, that's going to be equal to C squared. So I'm going to take U plus B squared and write it out. So I have V squared plus U squared plus 2UB plus B squared. So I'm just algebraically expanding u plus b quantity squared, and that equals c squared. Now, I'm going to look at this orange triangle here, and I can make the note it's a right triangle, so I know that v squared plus u squared is equal to a squared. So I can take that information, bring it up here, and say that v squared plus u squared is equal to a squared. So I am left with a squared plus b squared plus 2ub is equal to c squared. This tells me that c squared is not equal to a squared plus b squared, but c squared is actually a little bit bigger than a squared plus b squared, because it takes a squared plus b squared plus a little bit more to equal to c squared. So c squared is bigger than a squared plus b squared. Okay, now we'll do the same kind of manipulation with the acute triangle. So we have c squared is less than a squared plus b squared, and this is how this can be true. So we're going to drop down the height, and that divides b into two parts. We have y, and then we have b minus y. So I can see by the right triangle that c squared is equal to h squared plus b minus y squared. I'm going to expand that out. C squared is equal to h squared plus b squared minus 2by plus y squared. And then from here, I'm going to look at I'm just going to rearrange. Sorry, I lost track of what I was doing there. So I'm just going to rearrange so that I have c squared equals h squared plus y squared plus b squared minus 2by. So now I'm going to look at this triangle over here, and I have h squared plus y squared is equal to a squared. So I will take that information and plug it in, so I can say c squared is equal to a squared plus b squared minus 2by. So c squared is equal to a squared plus b squared minus a certain amount. Therefore, c squared has to be less than a squared plus b squared. Okay, so now we're going to take this and apply it. Is the triangle whose sides are 3, 4, and 5 a right triangle, an obtuse angle, or an acute triangle? So in order to figure that out, I basically take the two shorter sides and set them opposite the longer side and square them. 3 squared plus 4 squared blank 5 squared. And we have to figure out, is it greater than, less than, or equal to? So 9 plus 16 and 25, 25 and 25. So obviously that is equal. So since they are equal, I know it is a right triangle. Let's look at another example. Classify the triangle whose sides are 4, 7, and 5. So if you have a triangle who has sides lengths 4, 7, and 5, you're going to take 7 and put it on one side, and 4 and 5 and put it on the other side. 7 squared is either greater than or less than or equal to 4 squared plus 5 squared. So we'll multiply it out. 49 and 16 plus 25, we get 49 and 41. So 49 is greater than 41, and so since it's greater than, it's an obtuse triangle.